smallest to the largest. So when you sort the data, you can easily see the smallest and the biggest. Okay, so this is the sorted P ratio. And now we want to see how the data concentrates. Okay, at the point, I mean that we will find the center of the data. So actually, here are some sorry, let me back to. So apart of types of data and sampling methods, the characteristic that can be asking about the data first is the center. We want to see where are the data values concentrated, okay, and how much dispersion is there in the data set, how spread out are the data values, okay, and the shape of the data distribution. So I mean that are the data values distributed symmetrically, skewed, sharply, big, flat, bimodal, and so on. Okay. So here are the first three questions that we can ask, okay, about the data set, a part of type of data and sampling methods. Center, variability, and shape of distributions. So let's back to the data set. So here, first, we will use the stem and leaf displays. So this is a simple way to visualize the data set. First, you need to form a table consisting of 3 columns. You see here, the first column, write the frequency. That means the number of times data values appear in the data set. The second one, same, and the last one, left. Wait, okay, I think it's better. I will back to this one. Okay. So we have a sorted 44P ratio. How can we sketch a stem and leaf displays? So you have to form a table consisting of 3 columns. Okay, so the first one, we will write the frequency. Frequency means the number of times a data value appear. Okay, so here, stem and leaf. Okay, so now first, let's look. We have a number of 2 digits. Okay, all the number here have 2 digits. 7 is the 10 digits will be 0. 0, 7, or shortly you write 7, 0, 9. Okay, so here we can divide the number into 2 parts. The first part is leaf. Leaf will consist of the last digits. Okay, and the stem consists of all the digits. So for example, here we start by the smallest one, 7. Okay, stem will be 0. the last digit will be 7. Okay, the last digit you have to write in the left column. And then number 9. Okay, we can use a space. You should use a space between the two left. Okay, anyway, it's not necessary. I will. Okay. 0, 1, 2, 3. Okay, so what else I think is better? I will write in other color. So here it should be 0, right? 1, 2, 3, 4. I missed 1, right? 5. So I need to, okay, get more here. Okay, number 5 here. Okay, students, so what I mean here, I mean that the stem must be increased each time by 1. So if even you do not have the number like number 42, you do not have, but you need to write the number 4 here. Okay, even there's no leaf here. Understand, student? So the stem must be increased each time by 1. Okay, now next, left 0, stem 0. So left will be 7, 9. So here, that's all. There are 2 numbers. So you can write here frequency is 2. And now next, the number 110. Okay, so 0. How many digits? 0, 1, 2, 3, 4. I have 2. I need to list all. Okay, student. Okay, 4. 1, 2, 3, 3 times. Okay, and then 1, 3 appeared 3 times. 4, 4, 5, 6, 6, 6, 6. 1, 2, 3, 4. That's all. No. 7, 7, 8, 8, and then 9, 9. I'm sorry. Okay. So let's calculate how many number in the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24. So you can write the frequency here. The frequency here means the number of leaf in this stem. Okay, in the first stem. In the 0 stem, first stem, second stem, okay, and so on. Number 2, how many? 0, 0, 1, 1, 2, 3, 4, 6, 6, 7, 8. Okay, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11. Three, how many number? 1, 2, 1. 7, 7, 8, 4. Okay, number 2, 1, 1 only, and 5, 0, 9. Okay, student. So here there are two, and you can sum all the number here. Let's see, 2, 3, 7, 8. 8 plus 6 will be 4. And then 44. That's right. Good. So how many data values we have? Actually, we have 44 data values. So you can control or double check, okay, the number of data values we have here, okay. So this is called the stem and leaf displays. Okay, so what we can gain from this stem and leaf displays. Actually, we know the range of the data values. The range is range from 7, the smallest, to the largest. Okay, 0, 7, 5, 50, 59. Okay, the range of data values. Okay, that's. And then what else? And here you can see where the frequency is the largest, 24, 24. So I mean that's the data values. The data values are concentrated in the first stem, in the first stem. Okay, so you see here. Okay, student, we have how many data values in the first stem? 24. Okay, 24 data values. Okay, I let it be for 1 minute for you. Okay, so the data values dispersed from 7 to 59. I mean that's the range of data value. Okay, from 7 to 59. The data values are concentrated in the first stem. Okay, this is first displays. The second one, we use this data values. I will introduce you the order. Okay, here we go. If you want to see again, okay, the stem and leaf displays this data set. So if the data values, for example, we have 125. So actually we will, divide into, so this is, it will be leaf, okay, and this will be stem. Okay, student, so the leaf will be the last digit, okay, and the stem will be all the digits. And dot plot. Dot plot is an order symbol graphical displays the individual data values. So here, let me back to, I have already showed you in the summary. So here, the dot plot is a graphical display of an individual data values of numerical data on the horizontal axis. You know what is meant by horizontal axis? Okay, this is the horizontal axis. Okay, so here are some basic steps in making a dot plot. It's different from the stem and leaf displays. So stem and leaf displays is only a frequency tally, but dot plot, okay, we will plot each point data in the approximate locations. So here, first, you need to sort the data in the ascending order. Okay, so for stem and leaf display, you do not need to sort the data. But for the dot plot, okay, first step, you have to sort the data in ascending order. And then the second step, make a scale that covers the range. Okay, so here we have, you first have the sorted data, and then after that you make a scale that cover the data range. So for example, from 0 to CD, so it's enough to cover the data from 7 to 59. So we can divide into 6. Okay, student, so this is 50, 40, 30, 20, and then 10. So where is your data values? Your data values is 7, right? 7 to 50, 59. Remember you? So we can make a scale that's cover scale from 0 to CD. That's cover the data range 7, 59. Okay, and then you mark access the markation and label them. Okay, we have done already. So here we divide into 6. Okay, equally part. And then after that, you can plot each data values at a dot above the scale at its approximate locations. Remember that if more than one data values lie at approximately the same x-axis location, you can bias up, okay, vertically. So let's see here how we create the dot plot. So we have a, okay, 50-44 p ratio, right? So they here in this textbook, they create a scale 0 to scale range 0 to 7T. Okay, in my displays are writers only from 0 to CD. It's the same, no problem. Okay, and now we have to divide. It's up to 7, and this is 7, right? Remember, you student, this is 9, right? But okay, you do not need to write the number. Okay, you do not need to write the number, because if the data values too many, if we have too many data values, then if you write all the number here, is not really nice. Okay, so you should not. Okay, you should not write the number. Remember, we have 7, 9, for number 10, right, in the sorted data values, right, and so on. So this is 7, one number only, so we have 1 dot. Number 9, okay, nearby 10. So we have only one dot, but number 10, sorry, we have only 4. So we have 4, so we can, okay, plot the dot by upwardly like this. Here at 10, at this point, okay, we have 4 dots. Okay, it's by upwardly, right? And if I remember well, it's 11. We have 3 number 11. So here 11, we have 3 dots by upwardly. And one number 12, one only, and so on. Okay, student. So this is a dot plot. Okay, so dot plot, we can display for the n individual data values. Okay, so you can see that's the data values range from 7 to 59, and it's concentrated mostly on this interval, right? And the data values seem to be quite different from the majority. Okay, fine. There are 3 dots here. It's quite different from the majority here. Okay, so here is what you can earn from okay, the dot plot. So the range from 7 to 59, you know already, but a few data values lie between 10 and 25. Okay. Not all, but mostly, okay, data values lie in between 10 and 25. So what is a typical middle data values? 17 to or 18, 17 or 18, so somewhere here, right? And the data are not symmetric due to a few large p ratio. Obviously, you know what is meant by the symmetric. Symmetric means it will be symmetry above the center. So here, no, it's not. And you know, we can use also the stack dot plot, okay, to compare 2 or more groups. For example, we can, if you have, for example, here 4 groups, west, southeast, northeast, central, and then we can sketch the stack dot plot, okay, to compare the groups. So it can give us an idea of typical values within each regions. Okay. Okay, so let's practice a little bit, students. So let's do the number 3.1. First, make a statement lift dot and lift plot for the 24 observations on the number of customers who use a data Citibank ATM during the noon hours on 24 consecutive workdays. So here, actually, we have what data values how many observation? 24 observation. Okay, and this count what? On the number of customer. Okay, so this data actually the values is the numerical data, right? The number of customer who use the ATM during the noon hours on 24 consecutive workday. So do not forget that STEM and even for dot plot is used to describe the numerical data. Do not forget. Okay, student. So STEM and LIF used to display the numerical data. Remember you, what is the numerical data? Okay, it can be described, it must be numbers and described by discrete. Okay, it's discrete data or continuous. Okay, continuous, for example, P ratio. Okay, I have already shown you. Discrete, for example, here the number of customer. Okay, the number of customer here is counting numbers, right? So number of customer. Okay, student. So we will use the STEM and LIF block and dot plot to define the numerical data. Okay, so I let you do this problem in 5 minutes. Okay, because in the obviously for STEM and LIF plot, you do not need to sort the data. But in the second item, you know, okay, to make a dot plot, you need to sort the data. In both cases, I think you better sort the data first. What is the smallest? Smallest is 9. Okay, 9, number 9. Okay, number 9 and then number 15. You keep Y. Okay. Number 9, 15. Okay, I think it's better. Okay, number 9 and number 15 and then 51 only. Number 16 only 1. Okay, we have to do this manually. Otherwise, you have already the data set, then you can put it in. You can use the cell to sort the data, obviously. Number 17, no, there's no 17, 18, yes, once, 2. If I miss some number, please tell me. Okay, student. Number 19, only 1. Hope so. Number 20, no. 21, how many? 1 here, 2, 21. You should speak out. Okay. 21 and then 22. There is no 22. 23. No. 24. Yes, 124. Let me see. 24, once only. 25, how many? Only one. 25. 26, how many? 1, 2. Let me see. 26. 26 twice. 27 once. Okay. 28, no. No. 27, no. Once only. 28, no. 29, there's no. 29. 30, no. 31, no. 32, how many? 32 twice. 3 times. Huh? I missed
They
something.
have a 31. 31.
31 we have 1.
Sorry. 31 we have 1. Okay. Yeah, that's right. 32. 32 we have 3 numbers. 33. Let me see. 1, 2. Okay. 33, 2. 34, no. 35, let me see. No. 34. 34 we have, right? 34 here. 35, how many? 35, 1.
We have 2.
Where? 34 we have 1. 35 we have 2. Yeah, that's right. 35. 36, no. 37, no. And then and then 40, 42. Let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24. That's right. Okay, for 24 consecutive works day. Good. So we have already the sorted data values. And now, let's make a statement list. So remember we need to sketch a table of 3